All right, number 3 from 2019. Please make sure you've done this before you watch this video. This was a non-calculator problem. Let's go ahead and get started. Again, a graphical representation of calculus here. It says the continuous function f is defined on the closed interval from -6 to 5. So we are given the graph of f here, and we can see all the values from -2 to 5, but it says that it's continuous from -6 to 5. The figure below shows a portion of the graph of f consisting of two line segments and a quarter of the circle centered at 5, 3. So we have a quarter circle here, and it tells us a position of 3, 3 minus rad 5. So if I go over to 3, this y value is 3 minus rad 5. For part A, it says if the integral from -6 to 5 of f of x dx is 7, find the value of the integral from -6 to -2 of f of x dx. Well, at first glance, what I notice is that the lower bounds match, and we want the integral from -6 to 5. So if I'm looking at this graph, I know the integral from -6 to 5 because it tells me, but I can't see anything going on over here from -6 to 5. What I can see is the information from -2 to 5. So because I'm looking for the integral from -6 to -2, and I know the entire integral from -6 to 5, then if I know the integral from -2 to 5, I can figure out that missing piece. So we need to create an equation that relates all this stuff, and that's going to be the sum rule. So the integral from -6 to -2, the integral from -6 to -2, plus the integral from -2 to 5 is going to equal the integral from -6 to 5. So we can see that the upper bound of the first integral expression is the same as the lower bound of the second integral expression. The integrands are the same, so we can add those up, eliminating that middleman, so we have the integral from -6 to 5. So I have this equation, and I know that the integral from -6 to 5, this guy is 7, and I'm looking for this guy. So I've got to figure out this one. I've got to figure out the integral from -2 to 5. Well, the integral from -2 to 5 is just the area under that curve, bounded by the curve in the x-axis. The net area, I should say. So let's go ahead and figure that out here. Well, I notice that we have a bunch of changes here. Remember, you can't just find the area of a big triangle. It's bounded by the x-axis. So the first thing I notice is that this area, whatever that is, and the second area here, these two triangles cancel each other out because this triangle has the same area as that. One is positive and one is negative. So the integral from -2 to 0 is just 0. Now we have to find the integral from 0 to 5 there. And so that triangle and that triangle actually cancel each other out. That's the same area on each of those. One's negative, one's positive. So now the only thing I have to do is find the area of this guy from 1 to 5, and I can break that up and find the area of that trapezoid, and then I can find the area of that other piece in a second. So the area of that trapezoid is going to be 1/2 of 1 plus 3 times 1, because base 1 is 1, base 2 is 3, and then the height is the width of the trapezoid times, so 1. Then the area of this region, that's a kind of an awkward one because I don't know that formula. But what it told me in the prompt is that this is a quarter circle centered at 5, 3. So what I can do is find the area of this big square here and then subtract the area of the quarter circle, and that will give me the area of that purple region. So it would be 3 times 3 for the area of the whole square, and then minus 1/4 of pi times 3 squared. So again, 3 times 3 is the area of the whole square, and then 1/4 pi times 3 squared is the area of the quarter circle, and then if I subtract those two things, I'll get the area of the purple region. And then when I go to simplify all of this, this simplifies to 11 minus 9 over 4 pi. Now you may have approached that a little bit differently. You may have found the area of this triangle, the area of this triangle, then the area of this triangle, and then the area of this purple piece. but you should have gotten the same answers there. So now that I know the integral from -2 to 5, I can plug in the values that I know. So we would get the integral from -6 to -2 plus 11 minus 9 over 4 pi equals 7. And then from there, we can just solve for the integral expression. So we're looking for the integral from -6 to -2. So we're going to subtract 11 and add 9 over 4 pi to both sides. And so we end up with -4 plus 9 over 4 pi as our final answer. As far as points go, you're going to get a point for your sum equation. So having this equation was absolutely essential. You're going to get a point for that. You're going to get a point for evaluating the integral from -2 to 5. So you're going to get a point for this guy here, okay, the 11 minus 9 over 4 pi. And then you're going to get a point for your final answer. For part B, it says evaluate the integral from 3 to 5 of 2 times f prime of x plus 4 dx. Now I want to caution you because some students might be saying, oh, then I just need to find the area under the curve because I got an integral, so find the area under the curve. No, 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 no. If I'm finding the integral of, if I'm finding the area under the curve, then I'm finding the integral of f. I'm finding the integral of this function, and this function is f. But I am looking for the integral of f prime, so I cannot find the area under f to find the integral of f prime. So here, this is going to be a little bit analytical. How do I take an integral expression analytically? Well, I take the antiderivative. The first thing I know is that I have a constant multiple here. So what is the antiderivative of 2f prime of x? Well, that would be 2f of x. And then the antiderivative of 4 is just 4x. Hopefully you guys got that. The antiderivative of 2f prime is 2f of x. Take the derivative to see if it makes sense. It does. The antiderivative of 4 is 4x. And then we're going to evaluate all that from 3 to 5. So we're going to plug in 5. So we get 2 times f of 5 plus 4 times 5. And then we're going to plug in 3. So we get 2 times f of 3 plus 4 times 3. And then we'll subtract our two answers. So here, we've got to figure out what f of 5 is. Here's where our graph comes into play. What is the value of f when x equals 5? We can see that the value of f when x equals 5 is 0. And then 4 times 5 is 20. What is the value of f of 3? Well, f of 3, looking at the graph, that doesn't look good. But if you notice up in the prompt, it said that this has a value of 3, 3 minus rad 5. So f of 3 is 3 minus rad 5. So I'm going to go ahead and plug that in, and then 4 times 3 is 12. Going to simplify this, the 2 times 0 is 0, and then I got 20 left over, and then I distributed the 2 into both of those. So it's minus the 6 minus 2 rad 5, and then plus 12, and then go to simplify all that, and you end up with 2 plus 2 rad 5. As far as points go here, you're going to get 1 point for taking your antiderivative correctly. So basically getting to this line right here, you get 1 point. And then you get 1 point for your answer. So 2 plus 2 rad 5. For part C, it says the function g is given by this g of x equals the integral from -2 to x of f of t dt. Find the absolute maximum of g on the interval -2 to 5. So how do I find a maximum again? Well, I've got to find the critical points. So I need to take the derivative of g, because I'm looking for the maximum of g. Take the derivative of g. So when I take this derivative, the derivative of the integral, I plug in the upper bound and then multiply by the derivative of the upper bound. So that would say g prime of x equals f of x times 1, and then plug in the lower bound, so it'll be f of -2, and then times the derivative of the lower bound, which is 0. So we can simplify all that to say g prime of x equals f of x. From there, we're looking for the minimum, absolute minimum. So we have to find all our critical points. So our next step is to set our derivative equal to 0. So we'll say 0 equals g prime of x, or because that's equal to f, we could say 0 equals f of x. And then we can look at our graph, because that's the graph of f. When does that equal 0? Well, that equals 0 at -1, and it equals 0 at 1/2. And the reason we know it's 1/2 is because this line has a slope of 2 over 1. So if I go up 1, I have to go over 1/2 here. So when x equals -1, when x equals 1/2, and then also when x equals 5 are our zeros. All our critical points, though, would also include our endpoints. So we'd also have to include -2 and 5 again as our critical points. And then from there, because we're not looking for a relative maximum, if I'm looking for a relative maximum, my justification would be, well, when g prime changes signs from positive to negative. So this is a relative maximum here. But I'm looking for the absolute maximum, so I have to take all those values and plug them back into my g function to see which one is the greatest. So we're going to say g of -2 is equal to the integral from -2 to -2 of f of t dt. That one's easy because the bounds are the same. We get 0. For g of -1, that's going to be the integral from -2 to -1 of f of t dt, because we plug in -1 here. So we're looking for the area under the curve from -2 to -1. Well, that's just a triangle. We're moving in the right direction. It's above, so it's just 1/2 of 1 times 1, which is just 1/2. Then for g of 0.5, or g of 1/2, however you want to look at that, that's the integral from -2 to 1/2. Well, we already have this part, so we have to find this part here. So it's going to be 1/2 plus, so this is 1/2 plus whatever the area of this triangle is. Well, the base here is 3/2, or 1.5, and then the height is going to be -1 because it's below the x-axis. So it'll be 1/2 of 1.5 times -1, and then that would all simplify to -1/4. Now for g of 5 is the integral from -2 to 5 of f of t dt, and we already did that work from part A. That was 11 minus 9 over 4 pi. So from here we're looking for the absolute maximum. So which one of these produces the highest number? Well, the negative is obviously out. 1/2 is bigger than 0. So the question is 11 minus 9 over 4 pi greater than 1/2? Well, 9 over 4, that's going to be 2 1/4. 2 1/4 times 3, that's pretty close. So we're going to have to evaluate that, figure that out. But the reality is that is going to be greater than 1/2. So our absolute maximum is 11 minus 9 over 4 pi. As far as points go for this guy, you're going to get 1 point for stating that g prime of x equals f of x, so getting to this line here. You're going to get 1 point for your critical point value, so considering all these critical points here. And then 1 point for your answer with your justification. And again, justification implies all the work for the evaluating of all the values of g at those different critical points. So that's part C. For part D, this one, it seems a little out of place, and at first I'm thinking L'Hopital's rule. So what do we have to do when we first take a limit? The very first step in taking a limit is to substitute. So we would get 10 to the first minus 3 times f prime of 1 all over f of 1 minus the arctangent of 1. So we've got to figure this guy out. Well, 10 to the first is just 10, and then f prime of 1. How do I figure out f prime of 1? Well, this graph is f, so what is the derivative of f at 1? Well, that's the slope of this graph. The slope of this graph here is 2. We went up 2 over 1. It's linear. That's easy enough. On the bottom, we're looking for f of 1. Well, f of 1 is just the value of this function at 1, and so we can see that that value is actually just 1. So we got 1 there. And then the last part, it says, what is the arctangent of 1? So in other words, what angle measurement, what theta, will produce a value of 1 for tangent? And that value is going to be pi over, that one is wrong. It should say pi over 4. Let's fix that real fast. Pi over 4. So simplifying that, we end up with 4 over 1 minus pi over 4. As far as points go for this guy, you're just going to get 1 point for your answer. And this is another point. You've got to make sure you check substitution before you do anything else. This isn't an indeterminate form, so we're done with this answer right here. All right, that was question number 3 from 2019. So go ahead and grade yourself. The next problem we're going to be doing is a quiz, and that's going to be question number 3 from 2018. It's a non-calculator problem, so set your timer for 12 minutes and do it with all honesty and integrity, and then come back and watch the next video to see how you did.